Now it's recording right channel. Okay, so let's get started with the questions. Unfortunately, I don't have the questions uploaded to anywhere. So all I can do is really just to kind of talk about it. I can actually replicate some of the code on screen so you guys can see it. Okay. I think I had a request of starting from the last question first. Okay, so we'll go ahead and start with the very last question. Okay. So the last question, I can do the whole thing probably using just a text editor or spreadsheet. I think a spreadsheet is probably a better way to do it. All right, so here's a spreadsheet, and I'm just checking my input device, make sure the volume is about right, like that. That's good. All right. So there are certain combinations that are not possible, and you do not have to explain why those combinations are impossible. So we talked about this part already. When z is 1, none of the other ones can be a 1. So that's the that's pretty much the only one that can be on its own, can be set. So in this case, what you need the value to be is 131 itself, because 131 minus 131 is a 0. And when the result is a 0, the z flag is a 1, and everything else is clear. Okay, is that making any sense? That's one of the possible combinations. There are other impossible combinations too. Let me look up my own document. All right. Okay, so this is the same document that I shared with you on the whiteboard. We just took care of all of these ones, because when z is 1, none of the other flags can be a 1. So now we just have to deal with all the possible ones. These are all the possible ones, but these examples obviously may or may not work in your case. So we'll go ahead and try, let's say, this one here. Okay. In other words, we want the result to have just the overflow flag being a 1, and everything else should be clear. Okay. And let's switch. I'm switching back to the spreadsheet here. So let's see, look at the combination. Overflow is 1, everything else is cleared. So in this case, we just want the overflow to be a 1. Now 131 is a tricky one, because 131 is actually a signed number. It can be interpreted signed or unsigned. You have to look at the bit pattern. So with 131, we know that most significant bit has to be a 1. Now how do I know the most significant bit has to be a 1? Is 128 or more. Okay, 128 or more means the most significant bit is a 1. So in this case, how can I cause an overflow to happen? The number that I'm subtracting from is negative to begin with. So how do I generate an overflow situation? I subtract a non-negative amount from a negative amount and end up with a non-negative amount that will trigger to be an overflow. Okay, so how do I, how can I make that particular situation happen? What about, just make it subtract the largest possible integer, like 127? Do you think that would do it?
Yeah.
That would do it. Okay, because if you look at 131 minus 127, the sign flag is off. You look at the carry flag, it is off. If you look at the 0 flag, it's off. But when you look at the overflow flag, it is a 1, because you're subtracting a non-negative quantity from a negative quantity and then end up with a non-negative quantity. Okay. Let's go back and look at all the other possible combinations. This one is easy. Now, it really is not as easy as you think. This one has all the flags turned off. In this case, 1 minus 0 will generate that case. But in your case, it doesn't work. Okay? But you can always, just kind of say that, what happens when we subtract 0 from 131? When you subtract 0 from 131, then the sign flag is going to be on, but all the other flags will be off. Because 131 minus 0 is 131. But when you look at it as an 8-bit number, the most significant bit is still on, and that's why the sign flag is on. The overflow flag is a 0 because it doesn't cause, it doesn't trigger an overflow situation. the carry flag is off because it doesn't trigger a carry situation or borrow. And then what is the last one? The Z flag is off because the result is non-zero. It is 131 itself, and that's why in this case only the sign flag is on. All right. Let's see. We took care of this one, so that's done. We took care of. Okay, let's see if we can make the carry flag, turn on. Okay. So in this case, we have 131. When you want to look at it, when you want to evaluate, when the carry flag or the borrow flag is going to be turned on, you want to look at things from the unsigned perspective. In other words, we have to subtract a number that is greater than 131 to cause the borrow to turn on. Well, 132 is going to be more than 131 from the unsigned perspective, and that will for sure, trigger the carry flag to be set. The Z flag for sure is going to be off because the two numbers are not the same. How about the overflow flag? Overflow is off, okay? Because you are subtracting a negative quantity from a negative quantity, and you end up with a positive number in this case. Okay? Actually end up with a negative number in this case, so the sign flag is on too. Because you end up with -1 in this case. All right. And then we take a look at, so we took care of this one. The question is this even possible? Can we just make the carry flag turn on, but without the sign flag? Well, think about it. If you have the sign flag being off and 131 is a negative number to begin with, that means the overflow flag is going to be on. So it is actually impossible in this case to get that particular combination. In this case, we have both the carry and the sign flag to be on, and that's basically what we're looking at this point. This one has just the sign flag on, and everything else is off, and that is possible. Oh, we covered that case already. And everything is off in this case. Okay, let's see. Can we create a case where everything is off? And the answer is yes. It is possible because you can subtract 130 from 131, and the result is non-zero. It is not a negative number. It doesn't generate an overflow. And what is the other one? It doesn't borrow anything because 130 is less than 131 from a unsigned perspective. So that will basically give you none of the flags enabled. And I think that's all the possible combinations. Everything else are impossible.
So there was a combination with that?
Sorry?
There was a combination with that?
Sorry, say again?
There was actually an option where there's
I didn't realize.
because I thought it was just a space.
I thought it was spacing.
I really thought it was just a space.
Well, it says right there, if a flag combination, okay, if a flag is missing, it means the flag is cleared. So if you don't see any flags, it means all the flags are cleared.
I wonder how many people missed that.
How many people literally blanked out on that
Anybody
one?
here get that one?
The blank one?
Put the wrong answer
Oh, you put something in the blank?
You put impossible. Okay.
That was the second time too. The first time I did think it was just a blank.
Okay, so that's the last question. So there are two combinations that are not possible with this number to begin with 131 to begin with. There are two combinations that were otherwise possible, but not possible in this case. All right. So moving on to question number 3. Question number 3 is kind of interesting. So I will introduce the. Okay, I'm just going to use another sheet here, and I'll go ahead and replicate the instructions. So we have move B value to AL, move B $0 to AH. Oops, AH. Add byte AL, add CB add with carry. 0 to AH, add word AX to AX, and then we have add byte again, AL to AL, JNC jump if not carry to L1, add byte $1 to AH, and then L1 is no op. Okay, so those are the instructions. And the question was, what do you know about each register for each line? And after each line executes, what do you know about AH as well as AL? Okay, I think these flip here. I think you have to put AH first and then AL, because AH is the more significant byte, and then AL is the less significant byte. Okay. Now with this one, it depends on your student ID, so you may end up with a different number. Okay, because you have to add up all the digits of your student ID, mod it with 5, and then the remainder is what you use to choose from one of these 5 options. And I wonder how many people did not get this part right because they did not calculate the remainder correctly. All right, so I'll just pick one example, 166. Okay, so in that case, 166, is here. And then we don't know what this one has because it is not initialized at this point. If you don't put a question mark there, no point will be deducted, okay? Because we are not doing anything at that point. You put a 0 here because that instruction clearly puts a 0 into AH. Okay. Okay. This is add byte AL to AL. Now, so what you need to do is to multiply this by 2. But because this is an 8-bit number, it can only represent values up to 255. Now you can use hexadecimal, binary, decimal, whatever, okay? Whatever you use to represent, but it cannot be 166 times 2 because an 8-bit number cannot represent up to that value. Okay, so you have to kind of mod it and only look at the least significant 8 bits. So in this case, if I want to do the calculation, I'm being very lazy here. I'm doing, okay. I think we can just do a mod, 2 times 166, 255. So it should be 77 in this case. Nothing is happening to AH because this instruction does not impact AH. If you don't want to leave anything in that cell, you can just leave it empty, which implies you're not, nothing is happening to it. Or you can just put a 0 there just to emphasize that it is continuing to be a 0. The next instruction is add with carry. So the question now is the carry flag set after add B AL? What do you think? It is.
It's set, but is it applicable in the
It is applicable because this is add with carry byte, which means it is kind of like a regular add instruction, but the carry flag is also a part of the equation. So you're adding the carry with 0 in this case to AH. So AH at this point becomes a 1. Is that okay?
Yeah, I think I got that right.
Okay, well that's good.
I got it right, but for a totally different reason.
For a different reason. All right. Okay. All right. So now we have add W AX to AX, which is basically doubling the value of AX. But what is AX? AX is really AL and AH, okay? So that means, what you need to do is to look at, this part doubling, and this part doubling is 154. It does not generate a carry to, kind of stuff it into the second one, and this one will just get incremented to 2, okay? Now, it depends on your particular question because you might generate a carry because of this, okay? So in this particular case, I started with a number that did not generate a carry in this case. And then we have add B, AL again. So in this case, once again, I'm going to use a mod operation here. 2 times 154 mod 255 is 53. Nothing is happening to AH in this case because it's an operation that only works on AL. How about the carry flag? After line 7,
Yes.
the carry flag is set, okay, because 154 plus 154 is greater than or equal to 256, and therefore the carry flag is set. So if the carry flag is set and this one says, skip around the add B instruction, that means I cannot skip around it because I only skip when the carry flag is cleared. So that means okay, so nothing happens here. That means I have to go through this instruction, adding 1 to AH. So AH at this point will be 3. Nothing is happening to here, so 53 is still there. So by the time I get to the very end, AH has 3 and AL has 53. Yep.
So would that mean row 8 gets skipped then? If we wrote in skip?
Say again?
If you're looking at your table, row 8,
Row
would that
8.
line get skipped because the carry flag is set?
It is not skipping because the carry flag is set. It skips only if the carry flag is not set.
Okay.
Okay? And something is not right here. Okay, this mod is wrong. It should be modding 256 and not modding 255. So, my bad.
You just
Because I look at the number, it doesn't make sense. So I should just say this one refers to this one, and like that. And this number is off too because it's also modding 255. It should be modding 256, and this number is twice of that. There we go. Okay, so these are the actual values. I'm sorry about the confusion here. Okay. Are there any questions? What do you think the whole operation actually did? It's the same as left shifting 3 bits. Because if you look at the value, okay, if you look at the value represented by AH and AL together, we are looking at a value of 3 times 256 plus 48. How do you think this value relates to this value here?
times 2 is the third.
It's not times 2, it's
Times 2 to the third. Moving to the left.
okay, well, let's take a look. This value divided by this value. That's not right.
It's not.
It should be shifting 3 times. I messed up something here. Okay, let's start again. This is 166. This is 0. And this is 2 times 166 mod 256, which is 76. We put 1 here. Okay, let's just double check. 1 times 256 plus 166, 422. That is not right. One 66 times 2 is not that number. It should be 332. I messed up something here. Okay, let's see. This number minus 2 is 76. So this one is right. C5 is this number plus D2. Oh, okay, I figure out why. It's not plus D2, it has to be plus D4. Okay, so that part is right. Okay. And then when we do the multiplication by 2, this is multiplied by 2. And that's correct. This is multiplied by 2. From here, that is correct too. So when we look at 2 times 256 plus that number, it is 664. That is still correct. Add B, AL, so it's twice of D6. And we mod it. Oh, I know why. This number is not shifted. The most significant bit is not actually shifted in this case. So the end result is, this is correct. This is the correct end result, but it doesn't actually do the shift 3 times. It's more like 2 times and a half. Alrighty. Okay. Let's look at question number 2. Moving back up to question number 2. But remember, question 2, 3, and 4, they carry fewer points. Each one only has 20% of the final grade of this particular exam. Okay, question number 2 in this case, I'm gonna use a notepad for this. Alright, so in this case you have to implement JNL L1, and in my particular question I can use jump, JC, JZ, JNO, and JS. Those are the instructions that I can use, and I want to implement this particular instruction. Okay, so the question you have to ask, the first question you want to ask is, what is exactly JNL? Okay, JNL branches if and only if what?
Greater than.
It's not less than.
Right. So it branches if and only if
It's greater than.
O and not sign, or sign, okay, not O and sign, right? Because it's the exclusive OR of the sign flag and the overflow flag. Are we doing okay so far? In the notes, it basically says JL is to do it while it is like that. So in this case, it is actually the negation of this. So when it is not, this condition. Okay. The other way to look at this is to use a truth table. You can look at the overflow flag, the sign flag, and then you just basically say, should we jump? Okay. This can be 0, 0, 1, 1. While this overflow flag is a 0, the sign flag can be a 0, the sign flag can be a 1, the sign flag can be a 0 when the overflow flag is a 1, and the sign flag can be a 1 when the overflow flag is also a 1. In this case, they're both 0. Yes, we want to do a jump here. When they're different, we don't want to perform a jump. When they are the same again here, we want to perform a jump. So that's one way to look at the truth table to basically determine when are we jumping. We are jumping if and only if the overflow flag and the sign flags are the same. Either they're both cleared or they're both set. Are we still doing okay so far? Okay. All right, so based on the instructions that I can use, and I have to start with a JNO, it start with a JNO instruction. Okay, so once we know this table here, that means, the first one, I have to deal with this one, okay? So you basically have to say JNO to, I'll just say, are they both zeros? Okay, because, that's what I should be checking at that label, is whether the other one is also a 0 or not. Okay. So I'll just put a label here. Are they both zeros? Okay. And if I continue execution after the JNO, that means the branch did not happen, right? If the branch did not happen, what do I know about the overflow flag? If JNO did not branch, it is set. Okay, very good. Okay, so here I should say, are they both set? Okay. All right. And I am only allowed to use, the 4 instructions that I can use here. So I can only use JS to perform, are they both set? Okay. Well, that's pretty easy because, if I get to here, that means overflow is set already. If the sign flag is also set, then I can actually just branch to L1 right there. Is that making any sense? Okay. But I also have to remember to put a unconditional branch here to the end of this block of code. So I'll just say end block, and I'll put end block all the way down here, because end block basically means continue. Okay, a better name is just jump to continue, and this is my continuation point. So now I'm with the other branch. The other branch, by the time I get to where the blinky cursor is, it means the overflow flag is cleared already. I just have to check whether the sign flag is also cleared. Now, but I can only have one instruction to check the sign flag, which is JS. So at this point, I can say I have no choice but to use JS, because that's the only one that I can choose from. So if the overflow flag is cleared, but the sign flag is set, that means I should not go to L1, I should do continue, and the alternative is to branch to L1. And that's basically the code that I'm looking for. It's something that looks like that.
Didn't it say we have to start with JL?
It depends on your version. So depending on your version, the last sentence says, as an additional restriction, your code must start with some instructions. So some people get JNO, some people get JS, some people get, different versions of that.
So I would have just started with JS, go to L1.
Right. The S and the O are symmetric. So in this case, if your question is to start with J and S, you can just flip the S flag and the O flag, and it would work pretty much the same way. Okay. But that's the way to think about it. Use a truth table, or otherwise convince yourself, when are we going to the continuation point, and then from there, you have to use the available instructions to combine them so that together they will implement the JNL instruction. So it's really testing quite a few things. One, do you understand what is JNL? Two, do you understand how to use the conditional branch instruction? And then three is basically, can you put everything together? Because you might understand each individual item. Then the question is, can you combine all of these so that together they implement the JNL instruction? So that's question number 2, and we are moving on to the first one. The first one also has a few variants, depending on the type of X and the type of Y, they're different. Okay, one is a 16-bit integer, the other one is a 32-bit integer. And also the other variation will be the condition itself. So the ordering of the condition is also different depending on which version you get. It doesn't really make it any harder or easier, it's just different. Okay. All right, so let's go ahead and start with question number 1, and I'll just spell out the version that I have here. So you can just basically say apply this pretty much the same thing to yours, except your 16-bit and the 32-bit integer may be different, and then the ordering of the conditions may be different as well. So in this case, I have to check y is less than 200 first, and then we check x is not 1. And then last, we check x is greater than y. And then we have the instruction here, x gets y. And over here we have y gets x plus y. Okay, so this is the version that I'm getting. Your version is probably different because there are 6 variants to this particular question, and we have exactly 6 people here. So most likely yours is different. Okay, the chances are yours is different. I actually changed the program that I used to recombine all the alternatives, so it is more random than ever. I had to write some Python code to get that part done. It was fun. Okay, so to get this part, the first thing is, I'm gonna put some pound signs here. You don't have to do it. Okay, obviously you don't have to do it because you're using a different section of that sheet of paper. So you don't have to deal with this portion, but I do want to make it clear, and I want to interleave my assembly code with the C code. Okay, so first portion here is, we need a dot data section. X is a dot int, and 0 is fine, whatever you want, just reserve 4 bytes, I'm good. Y, on the other hand, is a dot word, because in this case it's a 16-bit integer. You only need to reserve 2 bytes for it. Okay, everything else will be in the dot text section because they're all in the code section. All right. So first thing first is, how do we get rid of or somehow boil the conjunction down to just comparison. Now, fortunately, this is just a simple conjunction. So with a conjunction, you basically say if the first condition is false, bam, go to the else case. If the second condition is false, bam, go to the else case. If the third condition is false, bam, go to the else case. Okay, because the only remaining part is okay. Well, if they're all true, then we'll go ahead and perform the then part. So that's why you basically boil this down to if y is greater than or equal to 200, go to else. Okay, and we'll just put an else label here. So you can see that I'm just working on this code step by step like that. And then you say, okay, let's say y is less than 200 already. We can confirm it. Let's check whether x is different from 1. If x does equal to 1, which means it's not different from 1, also go to else. And then you have your last reason to go to else here, which means when x is less than y, also go to else.
Less than or equal to y, isn't it?
Sorry? Oh, less than or equal to, that's right. Okay. There we go. Okay. Once we have something that looks like this, we can actually boil this one down to just compare instruction. Now you have to be careful because you have to look at the actual type of y in this case. Y is a 16-bit integer, so you have to use the right width for the comparison instruction. So in this case, it is CMPW for 16-bit comparison, and it's comparing 200 to y, and we say jump if greater than or equal to, or not less than. If y is not less than 200, branch to the else label. The NL is important. It is not JNB. It has to be JNL because the numbers are signed. Okay. So if it is uint uint 16, then it will be JNB. But because it is using regular int, which is signed, it has to use JNL. Okay, this one compares x to 1. X in this case is a 32-bit integer, so that means we have to use CMPL for long comparison. 1 against x, and then we are branching when they are equal, so it's a JZ in this case to else. The last one is a little bit tricky because not only do we have two memory operands in this case, they are also of different widths. So what you need to do is to quote-unquote cast it first. And it gets a little bit trickier if you guys don't do the sign extension thing and just really pad zeros, even though technically it's not completely right. I'll just take it as scope. Okay, that's fine. Okay. Does everybody understand what I'm talking about? Sign extension versus just padding with zeros. Okay. Do you guys want to see the sign extension one versus the zero one?
This is the one where we're kind of we put like a 0 into AH and put.
Okay. Let me just do it, and then you can actually see how to do it. Okay. Okay. X is fine. X is already a 32-bit integer, so we don't want to mess around with X. We do want to take care of Y because Y is 16-bit. We have to somehow change a 16-bit integer to a 32-bit integer before we can actually compare the two values. Okay, so this is what we need to do. I just need a register. I'll pick register EAX. Okay, but before we even do anything, we have to compare word 0 with y, and then do a JS or JNS. Either way is fine. You can flip this part, because if it is signed and we have the sign bit on, we have to do the sign extension a little bit differently. If y is negative, you have to pad all the more significant bit to a 1. If y is non-negative, then you pad it with zeros. Now remember, I said this part is optional because I never really talked about this in class. So for people who did this part correctly, I'm considering extra credit. But if you just do a padding with 0, I'll give you full credit for that. Okay, even though it's not entirely correct, but I will do the entirely correct part here. So I'll just say y is negative. Okay, which means if I'm not branching, y is non-negative. If y is non-negative, I can move along 0 into whatever register I want to use. In this case, is EAX, JMP to compare XY, and then compare XY is here. On the other hand, if y is negative, I have to pad everything with zeros first. So I have a move long, -1 or 0x f into %EAX. Basically, I'm padding everything with 0. So by the time I get to compare XY, registered EAX is padded correctly, either with all ones or all zeros. So at this point, I can move the least significant 16-bit into it. So move W, in this case it is Y into into AX, which is only the least significant portion of EAX. And at this point, this will finish sign extending Y. At this point, I can actually do the comparison. The code here wants to compare X to Y, which means the compare long instruction has to kind of reverse the order, which means Y, which is already in EAX, is the first operand, and X is my second operand. In this case, we want less than or equal to, which means it is not greater than. So J and G, if not greater than, go to the else label. Okay. And that basically finishes the comparison part. Once we have the comparison part done, because I still have Y stored in EAX, in this case already sign extended, I can just move EAX into X in this case because it's already sign extended correctly. And I have to remember to jump to end if, because otherwise it will go through the else block also. So end if is a label that is put here. And this is the only part that is left to do. I can just do an add long instruction. X is already 32-bit. EAX is the sign extended version of Y, so I can just do that. But when I store the whole thing back into Y, I have to do the truncation, which means I'm only moving the least significant 16-bit of EAX into Y, and that is also known as AX. Put that into Y, and that's the solution to the first question. Are there any questions about this one? So your variant can be a little bit different, depending on the ordering of the comparison, and also which one of the two is 16-bit versus 32-bit. But the rationale or what you need to do to sign extended and stuff like that will be identical. You still have to do pretty much the same thing.
You don't have to sign extend the other direction.
Sign extending the other direction?
Well, if for instance, let's say your 32-bit number was -10.
Okay.
If you just truncate that,
You can truncate it safely.
well, if you do just truncate it safely, it's just going to be 10. It's not going to be negative anything.
No, it will still be -10, because -10 is right, because it already has a whole bunch of ones already padded. You're just cutting off the most significant ones, which doesn't change the meaning of the value.
I wasn't thinking the false zero complement. I was thinking just the sign bit.
Okay.
I wasn't thinking of all the other F's.
Yep. Okay. So that's basically the solution to the entire test. Any questions?
How many points would you take off if I did J and L? J and B instead?
I'm going to make a laundry list of all the things that I'm looking for, as well as the right ordering of the instructions. I cannot just say I'm looking for this instruction or this instruction, because they can be in the wrong place. So I have a laundry list of all the things that I'm looking for, and then with each one I have a scale just like last time, whether it is completely correct with, complete and entirely correct, or it is partially correct, or it is not correct, or it is missing entirely. So I have to kind of use a rubric for each thing that I'm looking for. So you will see your score to be kind of like last time. It's going to be kind of complicated because each question has multiple things that I'm looking for, and then within those multiple things that I'm looking for, I have to rescale the whole thing to 40% of the test. So but it will be all spelled out. It's going to be spreadsheet generated.
Did you ever give our exam 1 back?
I will give it back to you. The previous one?
Yeah.
I tried to give it back to the class, but some people were missing when I did that.
I think you gave it out during lab.
Did I?
No.
Okay, so that's why you guys didn't get it, because I was handing it back during the lab time. Okay, well you can have it back to me. I have no intention of keeping your exam, since I created the question to begin with. All right, so I can stop the recorder and then upload it right away, and you guys can